Now, I know half of you did not listen to the video, and if you did, you heard Charlie Brown's teacher because you guys refused to actually pay attention. Okay. So, I know, wah, 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 wah. So I'm going to go back and I'm going to teach you the CERT concept. What I need you guys to understand is every single thing in this section revolves around the formula PERT. What does A represent in the formula PERT?
Wow.
The balance in your account. A is your balance in the account. What does P stand for in the formula PERT? The initial amount you've invested. E is the number. What does R stand for?
Rate.
Your rate. And what does T stand for? Time. Now, that is exactly the same concept here. We're changing the letters to be Q of T is equal to CERT. Q of T is the quantity, or quantity left. The quantity left. So it's an amount. It's your balance. Do we understand that? C is equal to your isotope initial quantity. So it's the amount that you started out with. In other words, your investment. Do we understand that? R is your rate, and in this case, it's exactly the same letter. It's still rate. T is still going to be time. Now, the difference between this problem and the previous problems asked that how long is it going to take to double your money in your account, correct? Or triple your money in your account. Well, this is talking about half-life. Well, now it's saying, well, how long is it going to take for you to have half the amount of your initial quantity? Does that make sense? That amount is given to you in years. It's not saying that it's going to take half the quantity and that's what that's equal to. Yes, there will be half the quantity there, but it's giving you the amount of years it's going to take to get to that quantity. A lot of blank stares, a lot of people dozing off in space. Okay, stay with me, folks. So, the problem with this is, just like we had previously, I'm going to have, with the doubling and tripling, I'm going to have a half-life formula. Half-life would be half of C is equal to C e to the RT. Because C was my initial. So I'm going to have half of that left over, correct? So what happens to your C's? So I'm going to have 1/2 is equal to e to the RT. Well, that makes sense considering my double was 2 is equal to e to the RT. My triple was 3 is equal to e to the RT. So half of my life would be equal to 1/2 is equal to e to the RT. Does that make sense? Okay. So now we know where this formula comes from, correct? And why we're using it. Now, we need to use that formula, that information, to solve this problem. It says that this isotope, do I care what the isotope is? 226Ra? It means absolutely jack diddly squat. All I know is it's Ra. Anybody know Ra is off the elements, table of elements? Is it radon? I think it's radium. Okay. Either way, that's one of those lovely little isotopes, one of the elements off there that they made an isotope out of. I could care less about it. Doesn't mean anything to me. I just know mathematically I can make it come out to how many years it's going to take for it to go away. Okay? It takes, for half of this amount to go away, 1,600 years. Well, that means my initial amount was 10 grams. So I have how much left after 1,600 years? 5 grams. Does that make sense? So was that the mathematical problem I was meant to do? No. Why would they give me the half-life of 1,600 years and the initial quantity of 10 grams? I don't care how much is left. What do I care about? How many years it would take to do something? How many years it would take for this, to get this amount? Okay? Well, in order for me to know that, I have to first know how fast this isotope is what? Decaying, decomposing, right? So what do I need to find here? The rate at which it's decomposing. So in order for me to use the rate, I have to use my half-life formula. So 1/2 is equal to e to the RT. So half of my life is going to take 1,600 years. Do we understand that? It's going to take 1,600 years. Which means I need to divide by, or I need to take the natural log of both sides. And when I take the natural log of both sides, my natural log of my e cancel out, and that's why I have 1,600r. Now how do I find my rate? My natural log of 1/2 divided by 1,600 is equal to my rate. So I come over here. I want a calculator page. I'm going to take 1,600, the natural log of 0.5, and divide it by 1,600. That is my rate at which this isotope is decomposing. Do we understand that? Well, let's think about that a minute. What does that number represent? How many of you would question if you got that number? You're going to sit there and you're going to question that, right? You're going to be like, that cannot possibly be right. Well, why can that not be right? Because it's negative. Well, okay, it's negative, but that means you're decomposing. Should your rate be negative if you're decomposing? Yes, it should be a decreasing function. That's what it means to decompose. It's a decreasing function. So is negative okay? Okay, why else would you question it? Because there's so many zeros. Well, that just means it's an extremely small rate at which this thing is decomposing. Well, let's look at the information they gave us. The information they gave us is that it's going to take 1,600 years for 10 grams to go down to 5 grams. Let's think about that a little bit. 10 grams. How much is 10 grams? There's this, how much is 10 grams? Okay, so give me an amount. Can you hold 10 grams in your hand? Can you hold 10 grams in your hand? Okay, my point is that's taking a really long time for 10 grams to go down to 5 grams. 1,600 years is a long time, right? So does that mean that this rate makes sense of being negative 0.000433? Yes, it's a very slow rate. So is that logical? My rate is negative 0.000433, which is a percent of 0.04%. Okay? Now, that's my rate. Now, why do I need my rate?
You plug it into fine, not after 1,000 years.
Because I need to know how much I'm going to have after 1,000 years. Well, let's think about that. If my initial amount is 10 grams, and half of my grams is going to be 5 grams, right? And that took 1,600 years to make it be 5 grams. Approximately how much am I going to have after 1,000 years? You think 8? Well, we know it has to be less than 10. And we know it has to be more than 5. Do we understand that? So we're going to come back over here and we're going to calculate this. So I'm going to go right back to Q of T is equal to CERT. Q of T is the amount after 1,000 years. Do I know that? No. That's what I'm trying to find. C is my 10. E, I don't know. My rate is 0.000433, and my time is going to be what? 1,000. So what is going to be my answer? Well, I'm going to come back over here. Watch how I do this, please. I'm going to take 10, E, and I'm going to go up here. I'm going to grab that and hit enter. Do you see how I'm using that decimal? Times 1,000. Is that a logical estimation of how much I'm going to have in 1,000 years? Yes, it's below 10 and it's above 5. So I'm going to have 6.48 grams left. Do we understand that, yes or no?
So it's just not hitting the halfway.
It's not hitting the halfway. I mean, we still have 600 years left to go before we hit our halfway. Do we understand that, yay or nays? Okay. Now, what's the difference between that one and 20? 20, I don't know my initial. But what do I still have to find first? I still have to find my rate. And then I plug in my formula to get the rest of the information. Do we understand that, yes or no? Do I need to do 20 or do you guys understand it?
You do.
Okay, I go right back to my half-life. So I'm going to have 1/2 is equal to e to the RT. How long does it take my half-life? Well, my half-life, it took 1,600 years, right? We already calculated this. It was exactly the same amount of time before in number 19, right? So my rate at which this is declining is still exactly the same as it was in number 19. So I'm not going to calculate it over again. However, this time, what changes?
Years. Time after time.
I know my amount after 1,000 years. So where does that 1.5 grams go? Does that go for Q of T, C, R, or T? It goes for Q of T. So this is 1.5 is equal to C, I don't know. E hangs out. This is negative 0.00043 times 1,000. And how do I get rid of that? Divide by it, because it's just a number. That's the rate. The 1.5 is the amount after 1,000. So 1.5 divided by e to the negative 0.0000433 times 1,000. And that's going to equal my initial amount.
3.31.
So I have 2.31 grams. Do we understand how to do this on the back of your worksheet now? Yes or no? I need visual here. Do we understand this? Visual or verbal? Okay. Now, what did I say at the beginning of this lesson? This entire lesson revolves around what, folks? Search and search. Okay? Now, this is number 6. Yep. The population P in thousands of Bellevue, Washington is given by P is equal to 110 E K to the T, where T equaling 0 represents the year 2000. Okay, well, let's think about that. P is what? Population. So let's put that into our PERT. P is the population, which refers to my balance in my account, correct? Or the amount of my isotope left over, right? So P is my balance. It's my number of people in my city. We all get that. 110 would represent what here? What did I say? It represents P. What is P?
Balance.
Okay, no. What did I say revolves around this entire lesson revolves around our formula? PERT. What is P in the PERT formula? P in the PERT, it's the initial investment. So what does 110 represent here? What does it represent? The initial investment or the initial population. Well, how can you have an initial population? You started off at what value? 110,000, right? But that has to represent what in time?
0.
0. Why does it have to represent 0? Because it has to start at 0. So in other words, if you plug in 0 for T, right? You plug in 0 for T. What's 0 times K? 0. What's e to the 0? What's 110 times 1? So my population at year 0, meaning my initial, is 110,000 people, right? Does that make sense? Okay, you don't need to write that down because it should be all right here. it should make sense in the formula. But what does year 0 represent? Year 0 represents 2000. So what you're telling me is I have an ordered pair, right? At year 2000, my population was 110,000, which is actually the 0.0110. Do we understand that? This is the year, this is the population. Doesn't that make sense? Doesn't that make sense? Okay, why am I telling you this? Because every single thing in these formulas revolve around PERT. 110 is going to be your initial. If you look down at number 7, what's 250 represent? Your initial. At time 0, right? We don't know what T represents in that problem, but we still know that 250 will be our initial. Do we all understand that, yes or no? So we know for number 6 that the initial amount of population at year 0, which represents 2000, was 110,000 people. Yes? Okay, so now we read the next sentence. So in 1980, the population was 74,000. So let's think about this. So if you make a nice little timeline, I have 0 being 2000, right? In 1990, that would be what? Negative 10. And in 2010, that would be 10. So what's 1980? Negative 20. Do we see that? Yes or no? So over here, this is going to be 2020 to give me 20 up there. Now, which are we using, the top or the bottom? We're using the top numbers. Do we understand that? So what we have going on here is we have 1980 corresponds to 74,000 people, which gives me the ordered pair negative 20, 74. Do we see that, yes or no? Do we see that, yes or no? Why did I go from 74,000 down to 74? Because it tells me in the problem that P is in thousands. Yes or no? Okay. So we have all this information. Now, why in the world do I need to have that negative 20, comma 74? Why would I plug it in? Why would I plug in negative 20, first of all? What would be the point of plugging in negative 20? Okay, but I know the population was 20 years ago. And you're telling me I need to predict it for 2012 or 2020? Okay, how do I do that? What? I need the rate. I can't do any predictions without finding the rate at which the population is what in this case? Growing. Because I went from 1980 at being 74,000 up to 2000 being 110,000. So I know this function is going to grow, which means the rate has to be what? Positive. So how do I find the rate? PERT or CERT, or in this case, it is going to be that P is equal to 110 e to the kt. What goes where? 74 goes for P, 110 stays, E hangs out. What's K? It is something. What is it? It's rate. It just gave it a different letter. Do we understand that? So this is going to be my T, which is going to be negative 20K. Well, how do I solve that? Divide by 110. 74 divided by 110 is equal to e to the negative 20K. Keep talking. Take the natural log. Natural log of 74 over 110 is equal to negative 20K. The natural log of 74 over 110 divided by negative 20 is equal to K. So I come back over here to my calculator. The natural log of 74 divided by 110, all divided by negative 20. And what rate does that give me? First of all, is it a positive rate? Yes. If it would be negative, what would I know that I did wrong? I would know I did something wrong, probably keying it in, because it needs to be positive, not negative, right? So there's my rate, 0.198. K is the same thing as what again? My rate. Now, why do I need that rate? Because now I can predict, I can go back to this 110 e to the point 00198, and this time, what am I going to put in for time? Why 20? Because that'll be the year 2020, and how much is that going to give me? Well, 110 times e
163.40.
raised to that lovely rate times 20. What does that represent?
63,000.
163.5 thousand. So in 2020, the population will be 163,500 people. Yeah.
I'll say, I take the end, but I didn't put that one, actually, I spoke 0.0. I got 163.46.
It's going to be a rounding error. I would definitely try to use the original rate. It's going to be better for you. Because that's not going to round up as it is. I would use the original rate. Do we all see this? Yes or no? Okay, now look at number 7. Let's talk about 7. The number n of bacteria in a culture is given by n is equal to 250 e to the kt. Let's break that down a little. What does n represent? Which is your balance. In other words, it's your balance of your bacteria, right? What's the 250 represent? The initial amount of bacteria for when? For when? When what? When t is equal to 0, right? What is t here? Well, if we read on there, it says where t is defined in hours. So at 0 hours, I'm going to have how much bacteria immediately? 250. Does that make sense? Then it says if n is 280, what does that mean? That my balance was 280. When t is 10, what is t representing? So after 10 hours, how much bacteria am I going to have?
280.
280. Why is that number important to me? Because I can find the rate at which the stuff is, what stuff is growing? The bacteria is growing. Because once I can find the rate, what can I then do? I can
Time
find,
it takes to double size.
do we understand that? Yes or no?
Yep.
Okay? Do we feel like we understand this better? Okay. Now, we are almost out of time. I want to talk to you. You guys have homework tonight. Because I've basically done your homework for you today in class, haven't I? I'm not nice. Let's get that right, straight right now. No, I'm not. I'm being vicious.
So we're wearing pink in the scarf.
Perfectly fine.
So,
You guys owe me for tonight for homework, page 226.
All of that page is missing our book.
mine's
34, 36, 37, 41, and 42. That's pretty nice of me.
Yes.
Now, I now want you to come back here and I want you to look at something. Page 223. I've not covered one like this yet. Page 223.
Earthquake.
Magnitudes of earthquakes. Earthquakes are very, very important for you to understand. They come from logarithm functions, okay? And it talks about the Richter scale. It says in 2001, the coast of Peru experienced an earthquake that measured 8.4 on the Richter scale. In 2003, Mexico experienced an earthquake that measured 7.6 on the Richter scale. Find the intensity of each earthquake and compare the two intensities. Now, if you look at page 227, okay, it gives you the same exact concept, the Fiji Islands, Central Alaska, Northern California, okay? What you have to do is you have to look at this formula over here, okay? Right on the top of the page, R is equal to
I over I.
on the Richter scale, the magnitude R of the earthquake of intensity I is given by this, where I sub 0 is equal 1 is the minimum intensity used for a comparison. All you're doing is plugging and chugging, folks. Do we understand that? All you're doing is plugging and chugging. So if you look at this, they tell you that R is 6.5, and they're going to let I sub 0 equal 1, and you have to plug and chug to find it. Are there any questions over what I just talked about on this? I mean, it's literally exactly the same as this problem right here. Okay? So follow it verbatim. Now, if you look at 34, 34 is depreciation. Well, first of all, the word depreciation tells you what about your rate? It's negative, okay? If your rate's not negative, then you've jacked up the problem. A computer that costs $2,000 new has a book value of $500 after 2 years. Hello, this is exactly your life. It's no different than buying a car and walking off the car lot with it. Or driving off the car lot. Okay? Find the linear model, mx plus b. What in the world does that mean? If I want a linear model, in order to find the linear model, you have to have how many points to make a line? 2. Well, do I have 2 points? What was the initial cost brand new? So I had 0, 2,000. And then what's the next point I would have? $500 is how much it's worth after how many years? There's your 2 points. Can you find the equation of the line now? Slope is y2 minus y1 over x2 minus x1. Right? Find the exponential model. Well, now they're giving you v is equal to a e k to the t. Okay, stop. Don't give me that look. What's v? What's v? V.
Notice a 2,000 here.
It is the balance. What's a equal? The initial amount, which would be 2,000. And then k would be your rate, and t would be your time. So you would know 500 is equal to the 2,000 e k to the 2. And you can find the rate, and then you can find the general formula. Use the graphing utility to graph the 2 models. Which window depreciates faster? Use each model to find the book values of the computer after 1 year and after 3 years. So you have to do an evaluation at 1 year and at 3 years using both models. Okay? 36. The sales in thousands of units of a cleaning solution after X $100 is spent on the advertising are given by S is equal to this jump. When $500 is spent on advertising, 250 units are sold. Complete the model by solving for K. Plug and chug, right? Estimate the number of units that will be sold if advertising expenditures are raised to 700. Well, what is that talking about there? You guys need to figure out what everything is there. X is going to be your $100 spent. That's how much you're spending on advertising. Okay? K is going to be your rate. 37. IQ scores. Immediately, you say IQ, what should you be thinking in your head? The bell curve, right? The bell curve. Which if you're looking at a bell curve, what are they always comparing it to? You're comparing on the bell curve. We talked about this. The highest point on the bell curve is what? The average score that everybody gets, right? So if it's looking at this one, it says use a graph utility to graph the function in part B. From the graph, estimate the average IQ score. What is that? The maximum point, right? It's asking for the maximum point. And 41 and 42 we already talked about, correct? Okay, the only one that should probably throw you for a loop is going to be 36, but I want you guys to think about it. Okay, we're done for today.
You put up the homework assignment.